Yes.
Okay, hello everybody. I am gonna present the effort made to go away from an old way of building stuff to a more modern one. I will try to explain why we did that, what were the challenges with the old one, what were the challenges with the new one as well, and give some idea of how much we gained from doing this migration. So some context, why and where did this work apply? So I'm working mainly on one big Git repository that holds many projects together. So I work on some of them, but there are many teams that contribute to this repository. It's mostly Java code, but there are a bit of other stuff, a bit TypeScript, a bit C# as well, but yeah, mostly Java. And a very important thing is we need to build on any platform. So that is a very, very strong requirement for us. So previously we were working with Ant as the build system. So for those that are not familiar, it's a declarative XML approach to building. So you describe task tag, and then a task may depend on something else, and it's quite verbose, but it's quite simple to use at the same time. So once you have installed Ant, which sometimes is tricky because of some environment variable, stuff like that, usually you can get what you want. This repository, being in Visuality, we are using for dependencies in-house packet manager called Pasta. So you'll see Pasta in slides quite a few times. That's how we got external thing we depend on, like for instance, branding libraries, documentation packages, things like that. And that is a tool that is cross-platform as well. So, this repository has been alive for quite some time, and many new projects added over the years, and we started to have very, very bad smells, like Jenkins build timing out because it took more than 2 hours, which is not good. So it was really time to do something about it, and it really looked at if we wanted to have some significant gain, we had to move away from Ant. So the option that was the more natural for us was to look at Gradle, since both Ant and Gradle are heavily Java oriented. So we looked at that, and there was a first attempt done at that, I think it was a bit more than 1 year ago. We started to see some light, but it was a huge task to actually migrate everything to that. So it kind of stopped there. We had done some proof of concept work with that, and it stopped. And we tried to resume that work, and what I'm presenting now is the work done end-to-end, and now we have completed the migration. So, what were the main issues identified with the previous way of doing things? First of all, the way the Pasta package manager works is that you declare your dependencies, and you, as a first step to prepare your repository after a clean checkout, you download those dependencies. The problem being that those dependencies are downloaded, but regardless of whether they are going to be used or not. So if you are looking at only a specific subtask, like typically running just the unit test, and you apply the regular steps that involve getting those dependencies, you will fetch a lot of stuff that you probably don't need. And not only that, but those dependencies are for some of them, global to the entire repository. So someone adding dependencies for his own project that might affect dependencies fetching for all projects as well, unless you take some extra step to filter out some stuff. And that dependency download step is somewhere where Jenkins spent a lot of time doing that over and over and over again. And considering that Jenkins nodes are virtual machines with not necessarily good disk or good bandwidth, etc., it could be like really, really slow, where before starting to actually trigger or code, just the point to get there, checking the repository and getting all the dependency, you could easily already be like 10 minutes, which was quite annoying. Ant is simple to use, but one thing that was not simple was managing dependencies between projects, because we have tried to segment our code in reusable sub-projects. Like, for instance, we have a component that we call the payload editor that is shared by many applications. It makes sense to have that in a separate project that lives on its own, that several other projects can reference. But doing that kind of dependency declaration in Ant was very much a manual process, and that combined to the fact that we had checked in project Eclipse files, there was a lot of duplicate work whenever we wanted to update stuff. So it was really, really not practical. And it was also quite painful, because most of the code in that repository is meant to be transpiled to JavaScript using the Google Web Toolkit, WIT. And that use a dedicated compiler written by Google. And that compiler had a different requirement than the regular Java compilation, namely that this compiler, in order to transpile to JavaScript, needs to have access to the source, not compiled class files like usually you do. Meaning that for compiling our code and running the unit test, which would be the plain Java way of doing things, we had to duplicate settings. One that would be the regular Java one that would be accessing to the source folders. So already we had duplication that was not easy to maintain. We also had a code generation step to generate some icon factory, given some SVG, to have some inline things that were saving us the trouble to keep downloading many, many small images when working on web applications. And that code generation step, of course, was in the way, because that was always the first thing you had to do to get started on anything. Otherwise, you would be missing a Java file and nothing would compile, which means that it was a bit annoying. Also, Intellij, we had many, many complaints by people that were interested in using Intellij, and it was not working easily out of the box. Eclipse was the preferred environment development tool when this project, this repository started. And because of that, Eclipse was kind of the first target. And we had checked in configuration files for Eclipse. Meaning that every once in a while we would see problems where someone would commit something and he would have written one of the dependency to something on his local disk, and that would fail the build for everyone else, that kind of problem. So that was also an issue. Some dependencies were checked in directly the repo, because some jar files were needed, and Ant is not very good at managing that kind of dependency. So some stuff were obtained via pasta dependencies, some stuff were directly checked in, but it was not a very satisfying solution. And we also had a bunch of warnings caused by the Eclipse plugin for GWT, which was trying to take ownership of our directory structure and see that, hey, you have this war web inf directory where you're supposed to have this and that, but I see that you have not moved your library. So a lot of noise that you had to explicitly ignore whenever you want to check, again, set up your repository. And finally, we had a build system that was taking care of the compilation, running the test and the packaging, but there was no support for additional tools that were very useful, especially for the front-end developers. We do a lot of web application in that directory, and one of the main thing to look at is styling. And because it's web, you have to recompile your style files that are organized in SAS format that is then transpiled to CSS, and we have this step because it's much easier for our front-end developer to maintain SAS version instead of pure CSS, which has a lot of redundancy that comes with it. Meaning that you had to recompile the styles, and then you had to reload the application, which is absolutely infuriating if you want to just change a few settings like move 2 pixels to the right. And to do that, the front-end community has a tool, which is Vogue, which is something that is running a small server monitoring your file on a disk, and some JavaScript that you put in your application that will live reload your CSS when it changes. So that is the way you want. You go in your CSS file, you change the value, poof, it immediately updates without reloading the application. That is how they need to work, because otherwise it's an insane waste of time. And that is the kind of stuff that we had no support for, so every developer working on code base had to basically bring his own Swiss Army knife to do it, some Python script, some widget that you put to Chrome to add something dynamically, whatever. We had to do better. So, that said, when starting to resume the effort that was started a year ago, first, the version of Gradle was very, very old. It was 3.5, and now we are at 4.10. And Gradle, I was completely new with that before starting on that, so I discovered as I went. And one thing I discovered very early is that Gradle is aggressively deprecating stuff from one version to another. Meaning that when I started, I immediately wanted to move to the latest version, which at the time was 4.9. And immediately stuff starts failing in various ways. First of all, the version of the build file that was checked in at the time was using a Jetty plugin. I was not sure why the plugin was there, or why it was needed, what it would do, but it was there and it broke. And the reason was that it had been deprecated when moving away from a Gradle 3 something to 4 something. And they recommended to use Jetty plugin instead, and it was absolutely not drop-in replacement. Like different APIs, absolutely no documentation to explain how to migrate from one to another. It was really, you Google it and say, yeah, you should use Jetty. Good luck. So, quite not straightforward. Then, the Compass plugin that was used to take the SAS file to compile them into CSS, that broke because they were using internal APIs. That had changed again. And this one was a bit trickier because in order to understand that it was failing because of an internal API, you had to do some kind of research to understand that the problem was that, and not just you doing something wrong. So I eventually figured that this was the problem, and for some crazy reason, there was a 2.0 version that was newer than the 2.0.6 version, and this one worked. Okay. So that was at least something we could start with. And then everything just went horribly wrong. Every once in a while, not consistently, I would get a gigantic stack trace. So gigantic as in like several hundred line stack trace. And it was really, really puzzling about what would be the root cause of that. Googling that made absolutely no difference. It was impossible to find any description of the error. Really, really puzzling. And by trial and error, I finally realized that in one of those directories that are not really us, but that kind of come with the old Eclipse plugin way of doing things, typically this webinf directory, there were a lot of stuff there that we have not put there. And that was somehow sneaking into the class path of what Gradle used to compile. And that, depending on the order in stuff were done, could trigger horrible things, like changing dynamically the version of the library used to parse the syntactic tree in Java, raising some horrible ASM injection internal error. Nightmare. So why were those files there? Investigation. It was the GWT plugin that was the culprit. In combination, no, actually it was the war plugin that was used in the build Gradle in combination with the GWT plugin. Because in Gradle you have this possibility of a plugin adjusting its behavior depending on the presence of other plugins. So if you had the war plugin and the GWT plugin, something would make the GWT plugin expose one of the features that we absolutely needed. So removing that war thing broke GWT. So it was kind of catch-22. So enough. It was time to get started with a clean state. So at this point, I just removed all the plugins and started from scratch by doing everything manually, because you have those basic tasks in Gradle where you can run regular processes, you can run Java commands, Java compilation. So we had the basic tool needed to actually do everything that we'd done manually previously with Ant. So that's exactly what I did. Removed all the plugins and do manually all the process execution. That worked. It was incredibly dirty and non-Gradle-ish way of doing stuff, but it worked. It was, of course, not really satisfying, since we were not taking advantage at all at the time of the power of Gradle that we were expecting to reap benefits from. So three big issues that all the configuration, all the tasks were declared in one big file, meaning that all projects would get all tasks. Which means that if you had a project like the one that was just using some TypeScript thing, this one does not need to inherit everything that is related to styling or compilation from Java to GWT. But everything, every project got everything. There was no concept of task grouping, so for every project, because they all got everything, well, we had no problem about accessing the task. But if we wanted to have this separation of concern and have only the relevant task for a project, you would still need to duplicate. So if a project, usually the GWT one, you always need the task that lets you compile for production and the one that lets you run in dev mode, which is the way we use for development. So those tasks always come together. So it means that you had to repeat those for each project that was a GWT application. And the logic for resuming tasks was just dead horrible, complete hack of what Gradle was providing. So it had to be done in a better way. And I started with the product that my team work on, where we have the regular web application and we have a read-only version where basically we can let people play with the system without any possibility to change some data on the server. So they can modify anything, they can destroy anything. And to do that, we have a task that is a tiny variant of the regular GWT compilation step. So it was typical, we want to do the exact same task with a different parameter. How do we do it? And then, after a lot of head scratching, I realized that, okay, we have to go back to plugins. which I was hoping we could avoid, but no, you have to do it the plugin way. That's how you're supposed to do it with Gradle. And the thing is, this time, that would be plugin that we control. So no hell dependency of if you update Gradle's version, some plugin might break, so you need to update that and that needs that. And that. We would be in total control. So it was less scary than using the third-party ones in the first place. So here is an example of what it actually looks like. So Gradle is Groovy oriented, which is something that is Java-ish, but with more script way of doing things, where you can omit types, things like that. So you can do what you want, Groovy and or Java or a mix. It's up to you. So here is how you do things. You declare a plugin, and your plugin basically declare a collection of things that you expose. So task, it could be data, it could be methods to run code directly. So in that case, my GWT plugin, I wanted to have two basic things done by it, doing the compilation for production and doing the dev mode thing that let the developer run and refresh the application without having to recompile and reload all the time. So you declare your project, and you say, okay, in that plugin, any project that imported plugin will get this and this and this and this. So here, you say, yeah, I want for any project that imports this plugin to create a task that will be named dev mode, that will have some parameters declared in a dev mode task that says what values it expects as input and what it's supposed to do when you execute the task. And you have some additional fields like description, help, something like that. And of course, you have dependencies. So here I'm saying whenever I want to run the dev mode to actually run my project in my web browser, I want also to have the style being up to date. So up, I have a dependency to the task that is responsible for recompiling the style. And this line is very, very, very important. And it took me forever to figure this line. Because what you want is to declare a task that can do something. That part is easy. But making that task reusable is something that you can only do if you expose these objects. And that was absolutely not straightforward for the Gradle documentation. They had a very, very nice tutorial about writing your custom task that explained everything, and when you were at the point where you wanted to reuse the task with different values, end of tutorial, boom, done. And to actually figure this out, I had to take a plugin that we had used before that I knew was doing that, and check the code on GitHub for that specific stuff and see how it was done. Because the Gradle documentation was not giving enough info on that. So this is the dev mode task. So we have some parameters that we can configure from the outside, and we have essentially what we want to run when the task is executed. So in that case, my dev mode task is just running the Java command that will execute the Google Web Toolkit code that runs the dev mode server and everything. I give it all the path it needs to the library we use, to the GWT dev mode code, and all our source material with this thing. And that's it. That runs Java command, and it works. What is very, very interesting is that at this point we started to have already a huge benefit from using Gradle. Because now, that is something that works out of the box, provided that you have listed your dependencies like that. If you update the dependency, that figures it out, everything automatically, transitive dependency included, which is much, much simpler for a developer, because the only thing you need to care is maintain your list of dependency per project, and that's it. And if you have a dependency to something like this, which is the actual UI main project. This one is the one that needs to care about the actual libraries relying on Google Code and SmartWit Code, which is another library that we use. If you update something here, this one will get it automatically. So you don't have anymore to care about project dependencies other than if you have a new dependency, you list it implicitly once and you're done. Everything would just work from there. And that is true for unit tests, that is true for GWT, that is true for when you want to inspect the project structure on disk to find all the source folders where GWT compiler need to find the .java to transpile that code. Everything you can get from that. So at this point, we already had a huge benefit from Gradle. You can inspect programmatically all the structure of your project, the dependencies, and you can walk down those paths and do whatever you want, and it just works. So the next step in getting goodies from Gradle was the dependencies, like library dependencies. So Gradle is natively good at Java stuff, so that was quite easy to get rid of all the checked-in Java library. So we had a couple of libraries that were checked in. Instead, just replace them with a regular maven dependency. In one case, the dependencies were not on public maven, so we just mirrored it in our own internal Vizerti maven, and that was it. So now we get everything. But there are also non-Java dependency that we need to deal with, like for instance, documentation packages. That's not Java, that's a zip file containing HTML, PDF thing. So the thing is, Gradle is not very good at handling that kind of non-Java dependencies. You can somehow make it happen, but it's a bit complicated. You basically have to try to fit in the model where you have those URLs, that you have a dependency that has a name and then blah, 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 and then version numbers. So if you really try, you can make it fit into the model, but it's not very friendly for non-Java stuff. And there were also completely other things that were not even pasta dependency that we were needing, like for instance, to do transpile operations from TypeScript, we need the TypeScript compiler, which is something that we need Node.js for. So that is something that is a dependency that we get from the web, from Node.js, a specific version. So all those dependencies were not ready to fit directly the Gradle way of doing things. So what could we do? Well, the thing is, Gradle has a cache in your home folder, and it's a very structured cache, but, well, we can do exactly the same, except that we do it by sneaking in our own subdirectory inside that directory. And it's absolutely okay to do that. And then, because you have a Gradle task that can let you download only if you do not already have it, you also have some possibility to only check and download if you have a newer version, otherwise keep the one you already have on the disk. So we can do that. And the thing is, we will not download twice. The first time you get it, it goes into this cache, and next time it will just skip the download step because you already have what you need. And what is making a big difference is that this Gradle folder is not inside our repository. So when you check out the repository with the old way of doing things, all the pasta dependencies were fetched inside it, meaning that if you do a clean checkout, you have to re-download again because you have lost them. And now that is living outside, so if I do a clean checkout, Gradle will figure out and download what it needs. If I do on the same machine another checkout somewhere, it won't re-download because it already gets the cache populated correctly. And that makes a lot of difference for Jenkins, because suddenly Jenkins does not need to re-download everything, because Jenkins has this tendency to wipe out clean the repository itself, but not this directory. So all the time spent re-downloading over and over again, suddenly we could not spend any more on Jenkins, and that makes a huge difference. And what we can do is fetch on demand when needed. Remember that pasta dependencies were fetched upfront before starting to actually do anything on the repository. Now we can have fine-grained tasks that will say, okay, when I need to do something, like here I have an Excel documentation example, that is something I want to do only when I want to build the full package. So when I'm running the unit test, for instance, I don't care about installing documentation at all. So that is a task that will do that. And I will make this task depend on the fetching documentation task. So this thing is responsible for checking out from wherever the place, in that case it's a pasta dependency, bringing that on my disk, and when needed, I copy from there. And that means that this fetch task is not executed unless I actually need the documentation step in my task, like I want to package everything. So no more fetching of stuff that you don't need. You really just download on demand what you need, nothing more than that. And that is absolutely powerful, especially with the unit test. Because this repository is quite big. We have many unit tests, and running them on Jenkins took a lot of time. And the dependencies were a big part of the time, but not only. And the thing is, when you want to run the unit test, it is plain Java. You don't need the GWT compiler, you don't need documentation, you don't need Node.js, you don't need styling stuff. It's just plain Java, which means that you have nothing to check, and it goes super fast. And then, on top of that, Gradle is really smart at not recompiling stuff that don't need to be recompiled. Much better than Ant. And that means that running the entire, all the tests in the repository, all of them, after a clean checkout, took 1 minute on my machine, which is already much faster than it used to be with Ant. That was kind of redoing the same stuff over and over again. Like I'm running the test for this project depends on this project, so I need to recompile that. And if after that I do the test on this project that also depends on this one, it would recompile anyway. So a lot of duplicate work all the time. And now it's 1 minute the first time. Run it again, it's 1 second, because Gradle realized that, oh, nothing has changed, everything is up to date, no need to rerun, recompile, nothing. Meaning that it goes really fast. And now, the elimination of dependency fetching for unit test plus this lazy approach in Gradle, now we have a Jenkins job that we can use to run all the tests on everything, on average under 1 minute, including Git checkout of the repo, which is really fast. And that means that we can basically afford now to run that virtually on every single commit, which is much better than what we had before, where it could be a lot of time before you realize that you had broken something. Then, Eclipse and Intellij. So, for Eclipse, it was and then with those manual generated class paths and project files that were checked in, and we wanted to get rid of that. Unfortunately, there is an Eclipse plugin for Gradle that does exactly that. It looks at the dependency that you have declared yourself, and it generates for you all those files. So you don't need anymore to check those files in. No more risk of having someone committing a dependency with a local file that breaks everything. It's much better. And here, I had a very good surprise. It worked on first try. On first try, I was almost not believing it. Gradle Eclipse, poof, open in Eclipse, and it just works. That was really cool. For Intellij, you can import directly build.gradle. and here it was equally unbelievable. It just worked on first try as well. So Intellij is just capable of figuring out everything. You just have to double click on this file and you're done. The only thing I had to do to get there is to remove the icon factory that we had. Remember, we had this code generation step where first we would download a package containing some SVG icons and have some code generation step to inline those basically as Java strings. And that was the last tiny piece that was in the way. So instead of trying to work around that, we agreed with the team that is maintaining those icons that the code generation would be moved in the same repo as the SVG, and there would be a job there that would be responsible for packaging those and putting them in our Maven repository. So no more code generation, and now we have a clean checkout, and immediately after a clean checkout, you double click on build.gradle on Intellij and you're up and running. Related and a bit unrelated at the same time, we also had in our backlog the project to get rid of Compass, the preprocessor for the styles. The reason for it is that it is deprecated, and it was also quite slow, because it was, unless you had deployed manually some pre-compiled version of it, it would involve running Ruby, which would involve either installing Ruby but some specific version, blah, 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 or you would need to avoid that Ruby dependency problem using JRuby, which is a Java version of it, and everything was quite slow, working but slow. But we were already using Node.js to do the TypeScript transpiling, so we asked our new front-end guy, Yarda here, okay, what can we do? And he said, yeah, the modern way of doing that is using Sass Node, blah, blah, blah. Okay, go ahead, do it. And he did, and it just works. Which means that we could get rid of yet more dependency and keep improving the speed of the build process, since that Compass part was quite slow. So, less dependency, faster build. It was really good to have that in the same go. And remember, we want to have this nice workflow for front-end developer where they can just edit the style and have something live update. Well, there is a Webpack mechanism for doing exactly that, for auto-watching the files and do something when the files are changed on disk. So we did that. And the thing is, now we were in a situation where we had the Google Web Toolkit dev mode that would just let us write the Java code, reload the app and see the result, and the code that would monitor on disk and recompile the styles, and the vogue mechanism to automatically reload the web application styles dynamically without having to reload everything. So 3 pieces, it was working, but if we could have everything together, that would be nice. The problem is Gradle does not support concurrent blocking task. It's really designed to process a graph of dependency where each task is supposed to complete and then you move on to the next one. So we can do it out of the box. But because we have plugins that are Groovy or Java code where you can put everything you want, we can do it yourself. And my first attempt was using threads that would run the task content, which worked beautifully on my machine and failed miserably on Windows because the thread model on Windows do not let you kill the stuff. Meaning that if you start a task, that triggers a Node.js something. When you kill your task, this one lives in the background forever, which was not really nice. So instead, well, plain old process, so then it works. So what we do is say, okay, I'm gonna create, so when I'm in the plugin that is responsible for doing the styling, and I realized that this plugin is also used in combination with the Git plugin, I will create dynamically a task that will do 3 subtasks, trigger 3 process, one for monitoring the style files, one for taking care of the auto refresh style, and one for the regular dev mode. And that will just do look. Actually, no, I don't have this example. It will just trigger 3 processes and just wait for it forever, and that's it. And it works. And suddenly you have in one command on your terminal everything at the same time. So no more custom trick. It just out of the box works. So why not go one step further? The product I'm working on, we have some cloud backend we want to be able to test against. And in that case, we need to have a proxy to take care of authentication issues, amongst the other things. So the backend guys have created a very, very nice tool, thanks almost to Rolf in particular, which is capable of running the local version of the client code against a remote backend. Well, the backend guys were nice enough to package it for Windows, Linux, and Mac, so suddenly we can run it automatically out of the box as well. So that's what we did. We have another task that will fetch that, install it, and then use that to trigger your proxy, and everything will just work. So right now, if you want to run the local version against the cloud backend that is live, all you need to do, clean checkout, go in the repo, one command, and you're good to go. The first time it will take some time to fetch all the dependency. The second time it will be much faster. And that's it. Now we have a build system with a one-line command. You get up and running immediately, which was really, really nice, because suddenly you don't have anymore to keep track of a lot of instructions about what to do when you start for the first time. All you need to remember is which command to run, and you're good to go. So that was very satisfying to be able to get there, even though I had to fight Gradle a bit to do that, and Windows threads. But in the end, I could get where I wanted to be. So I have to confess that my first impression was not that good, because there were so many issues that were kind of related. Like it really felt like a big hell of a plugin version that would be compatible one with the other. Those stack trace that I had to deal with in the beginning were absolutely horrible, because there would be usually some internal compilation library stack trace, the kind that you really cannot Google in a meaningful way. Really, really hard. So when something goes wrong with the build system, you're really on your own, basically. Also, since Gradle is relying on Groovy, you have to get familiar with the Groovy minimum, and Groovy has this script language tendency to be very, very permissive in how many ways, different ways you can write something. So you have many, many different syntaxes to do the same stuff, which is quite confusing, honestly. So my impression is that once you have found one style of doing things, stick to it for consistency, because otherwise it's really unreadable. There is also this philosophy in Gradle where you have the task configuration phase and execution phase. And that is something that you really need to spend a few minutes to begin with to clearly understand the difference, because it's really, really easy to introduce bugs by misunderstanding those phases, where you think you're doing something for the task, while it's not when you invoke the task that it's executed, but rather when the build.gradle file will be opened. So usually if you do something like copy a file from there to there, and if you do it at the wrong step, well, on the first try, because you may already have compiled, it may seem to work, because the file happened to be there, but next time you do it on a check build, on a clean build, it will fail because it won't be there. So you can get easily into a buggy situation because of that. And the Gradle documentation, there is a lot of stuff, but they tend to be very Javadoc-ish in the sense that every single method will tell you, yeah, this method does that. But the clear picture and good tutorials with a use case approach, like, okay, I want to do this, how do I do? They are clearly missing on that part. There is a lot of work done, but still, it's most of the time, at least in the part of the documentation that I had to look at, they tend to focus on the happy path. But I do not regret my Gradle journey. It's very laziness friendly. So everything about those tasks that do not need to rerun if you don't have a clear need to. A lot of predefined tasks have that automatically, like the task that can use to copy a file from there to there. That is out of the box doing that. And you can easily customize for your own stuff that laziness as well. So it's really, really easy with Gradle to not do stuff that you don't need to. That's really good. The integration with both Eclipse and Intellij is now super good. For Eclipse, we have to run once gradlew Eclipse to generate the file, and that's it. For Intellij, we just need to double-click on the file, and that's it. So much better than before. And now, for the developer experience, everything that was outside the build system, like style monitoring, things like that, now can directly go in there. So if we have new tasks that can be viewed as part of the build system, like let's say compile some release notes, that's definitely something that I know will be easy to plug there, so that one guy will write the plugin to do that, and everyone will benefit from it without having to remember every time, oh, okay, where do I do blah, 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 blah. So you can really put all the tools that you need as a developer inside the build system directly, instead of having the build system to do one thing and everything else be on your own on everyone's machine. So I'm very pleased by the result. Now it's much faster than before. It is quite clean, even though it is also a bit verbose. Not the same kind of verbosity as Ant, but a bit verbose still. But it's definitely worth it, and I hope that it's making life easier for everyone that starts working on this repository. And that's it. Questions?
I do have one comment. I noticed that when looking up documentation, if I look for Groovy documentation, which has been around much longer than Gradle, I usually get better results, but I'm not sure exactly where we draw the line between what's pure Gradle and what's Groovy syntax and such. Did you see exactly where we draw that distinction, like what Gradle added to Groovy to actually?
No. No. For me, that's kind of a gray area. What I've seen is that for things that are really Gradle things, like for instance having a task depending on another task, it's way easier to use the Groovy style, like task.depend, poof, that's it. You can do the same in Java, but then suddenly you have to import stuff and you have to invoke methods. So it's much easier to get started by looking at what you see in existing build files and replicating that behavior using Groovy. But since you can mix as you want in the plugin and in the task, it's really easy. You can have like an actual piece of Java code, like for instance triggering the process builders to get the task. That I've done using pure Java code that I already had from somewhere to do that. and that is mixed in some groovy stuff or doing stuff that I know can be done this way because I've seen it somewhere else, and I don't want to take the time to learn how to do that in Java. So this way of mixing stuff is very convenient, but where to draw the line, I'm not groovy savvy enough to know that.
Yeah, so one of the problems that you had with the initial attempt of trying to take what existed was the, I'm guessing, the quality or the state of existing plugins in
Yes.
Ruby. That they were things that might have worked at some point but have rotted over time.
Yes, exactly.
Is there a fear that that would happen with our own maintained plugins as well?
Maybe. I'm not so concerned because usually what I've seen from my very limited post-mortem of those plugins was that most of the problems were plugins that were using internal Gradle APIs. Like trying to access to some data structure that is internal to how a task is maintained internally. And that, I've made sure that we do not do that in our own plugin. So we tend to stick to really the public APIs only. So of course they can very well decide to deprecate public APIs as well. But I'm not that concerned about that.
Right.
It's really the internal stuff that are really, really scary.
So it's quite a number of years since I've last looked at Gradle in detail and the APIs it provides, but very early on it seemed like they didn't really have a separation between what was internal and what was not. It was basically just a big pile of dependency injection and how to do things seemed like yeah, you just need to figure out what worked and what didn't, and that whatever you did, that was the API. Is it now more clear?
Yes. It's clear in a very interesting way. They have really separate in different package structures the API, the internal APIs from the public one. And you can tell because you cannot Google for Javadoc on the internal APIs anymore. So if you want to learn about those, you have to check out the code and look at it directly yourself. So they really try to discourage people from using those. But still, because the nature of how Java code works, you can still access it if you really want to. If you know where to look at, you can do it. It's really discouraged now, but you can if you want. Yeah.
So you keep you try to keep all the dependencies in the .gradle folder of the home folder.
Yes.
What kind of sort of protections do you have if you, for example, decide to stop using a dependency and use a different dependency that sort of replaces the old one, and the old one is still, you know, in the folder? And does it? How do you check to make sure that you're actually using the new one that you replaced it with, rather than the old one?
Well,
does Gradle?
For Java dependency, Gradle takes care of that for us directly. And for the custom stuff like downloading documentation package, then it's the code that I put to download and put it there that will take care of that. So if there is a newer version of the dependency, then it will redo all the work. So if you have, let's say, the documentation package is suddenly updated on Pasta, next time you run, it will look, okay, you want to build, install documentation, depends on copy documentation, depends on fetch documentation. I look at the E tag from there, oh, newer version. So I download, and because this task is run again, all the dependency will be run again. So, which is why I choose to use this download plugin that is capable of doing that, checking E tags to precisely avoid that kind of problem where you could assume that, okay, the file is there, so I don't need that, but Jenkins maybe will check the newest and you won't get the same build. So it's, it costs you, I think, head request to figure out, do you have the latest version or not? Cool. And that's pretty much it.
So one of the reasons why there has been a trend to move towards making build systems like Jenkins, for instance, clean, basically wipe the directory and start from scratch, has been that the incremental, even though you have tools for doing incremental builds, they are not always perfect. And you can get in a state in which you basically need to wipe things in order to make sure that you have consistent builds. Is that something that you're confident enough to basically turn off wiping the directory, or and then do complete incremental builds on the build servers as well, or is it something that we are still think that there are scenarios in which wiping the whole thing and starting over is the only way to basically be sure that the build is consistent?
Well, I already did that for the unit test. For the unit test, we do not wipe, and because we do not wipe, we just check out. Especially if you work on master, you actually benefit from not recompiling everything because some of the stuff are already up to date. So, and for unit test, as far as I can tell, since we put that in use, I don't think we have ever had a failure that would have been caused by that kind of problem.
Right.
So for other full build, I don't know. I have not checked whether or not we do a full clean. But at least I know that for unit test, we do not clean every time, and it works.
Yeah. And if we do not clean on the build servers, is there then a benefit of having the package cache outside of the build directory? Is it basically the main goal there is to share downloads between different build jobs?
Yes, and avoid re-downloading over and over again the same stuff.
Yeah, but if you're not wiping between builds, so why would you reload download?
That's a good point. But the thing is, depending on what you check out and what you want to execute, maybe some dependencies will not be there. So, yeah, I guess if you do not wipe anything, you might be in a situation where you can accumulate stuff.
I'm kind of just trying to figure out whether how magical Gradle is basically, in the sense that there are very few build systems that kind of makes those very strong guarantees that you never need to wipe. And I haven't followed Gradle enough to know whether it has become one of those.
Yeah, it seems pretty reliable.
Okay.
If you want to have a clean, actually the problem is more about cleaning everything when you want to clean. Make sure that you do not keep outdated stuff. Our Gradle is really good at that. But I found it easier for cleaning to rely on Git instead, because Git knows what we are tracking, and it's much simpler to ask Git, okay, everything that you don't know about, wipe. Because if you want to do that in Gradle, then you need to have each task to declare exactly what the outputs are and what should be removed. And that's a bit tedious, and that's prone to error, to forget to update that. So.
Is there a risk for the .gradle folder to end up with loads of libraries that are now deprecated and not used by any project anymore, but they have been used at some point, and then the Gradle server will just keep that, you know, because it has no way of knowing that, oh, I don't need this anymore because all the projects have like now moved on to the latest version?
No, not really, I guess. But the nice thing about having everything in one Gradle cache directory is that if you want to start clean, you have just one directory to nuke, and you're guaranteed to start clean. So if you want to have like a scheduled job that every Sunday evening will wipe that, that guess is a nice, simple way to handle that problem.
I think we are all